Physics students, good afternoon. Mr. Fugit here. In this video, we're going to be looking at some concepts involving electric fields, and what we're going to talk about is the overall field between experience between two different point charges. Specifically, this video is going to help you with problem number 6 on homework 13 over electrostatics. So I'm going to read our problem statement and then we'll begin. It goes like this: find the magnitude of the electric field at a point midway between two charges, positive 48.5 times 10 to the negative 9th coulombs, and positive 94.3 times 10 to the negative 9th coulombs, separated by a distance of 74.9 centimeters. And we're given the value of our Coulomb constant. So here, as with always, all scenarios, it's important to start by drawing a picture. What I'm going to do is I'm going to draw our two charges. And to the left, 48.5 e to the negative 9th. That's not very good. E to the negative 9th coulombs. And to the right, our other positive charge. That was 94.3. Should draw this below, stay consistent. E to the negative 9th coulombs. Now, as with any point charge, it's going to create an electric field in the area surrounding the charge. So, for our blue charge, it's going to create an electric field pointing out, right? Because our source charge is a positive charge, it's going to want to cause positive charges to move out. So it's going to create a field pointing out. Now, our red point charge is going to do the same thing because it is also positive. So it's going to create a field that would look somewhat like this. Obviously, there are going to be more electric field lines, but we can just draw a few to give us a good picture of what's going on here. Now, as you can imagine, because this is asking us to figure out what the overall field would be midway between them, it's going to be our job to figure out which of those fields is going to be a little bit stronger. It's going to kind of win that battle. Now, as you can imagine, our field on the right is going to be a little bit different than our field on the left because there are two different source charges there, right? One is greater than the other. So it's going to be our job to figure out which of those fields is overall going to affect our middle point the most. So what we're going to do is we're going to start by solving for the field from our blue charge as well as the field from our red charge, and then we're going to compare those two. So we'll start with our blue charge. The field, as experienced by our point charge, will be solved like this: K times Q1 divided by D squared. Now we know K, we know Q, the source charge creating that field, and we know our distance from our source charge to that midway point. Okay? So E for the blue field is K, 9e to the 9th, times Q1, which is our blue charge. That was our 48.5 times 10 to the negative 9th coulombs. And then we'll divide by the distance between those points squared. Now, one thing that we have to be careful of here is that in our problem statement, we're given the total distance between those charges. And so the midway point is therefore half of that total distance. The distance I was given was 74.9 centimeters. So I'm going to go ahead and divide that by 2, which gives me 37.45 centimeters, or 0.3745 meters. And that distance does need to be squared. Again, we got that by taking our overall distance and cutting it in half because we're looking for what's going on at the midway point. So our blue field at this point has a strength of this: 9e to the 9th times 48.5 e to the negative 9th coulombs divided by 0.3745 meters squared. And when we plug that value in, we get a magnitude of our electric field of 3,112.29 newtons per coulomb. That is the electric field experienced at that midway point from the blue field. Now we've done that for one of our fields. Now we're going to do the same thing, but for the red field. So, same approach, K times Q1 over D squared. Now notice in our equation, only one variable is going to change here. Our constant is going to remain the same. We're still midway between those points. So the difference really here is our amount of charge, how big or small Q is going to be. So we'll plug in what we know. E is equal to K, 9e to the 9th, times Q1, which was 94.3. There we go. E to the negative 9 coulombs. And we'll divide by our distance, which remember is half the total, 37.45 centimeters, or 0.3745 meters squared. So what we'll do is we'll plug in what we know, 9 e to the 9th times 94.3 e to the negative 9th divided by 0.3745 squared. And when we do, we get a value for our electric field at this point of 6,051.33 newtons per coulomb. Okay. So what that tells us is that the field that we experience from the blue, or the overall amount that we feel from the red field is then greater than what we feel from the blue field. And we know that that's probably accurate because we have a greater amount of charge over here than we do in the red field than we do in the blue. Okay. So we have two numbers. What do we do with those? Okay. Here's what I want you to see. Okay. That at this midway point, okay, our particle, let's say it's a positive charge, is getting pushed some way by this blue field. It's also getting pushed this way by our red field, if you can imagine. They're kind of opposing fields, if you will. And because they're opposing fields, that means we need to find the difference between them. So we're simply going to take our two values and find the difference. So we'll take 6,051.33 minus 3,112.29. And when we do, we get an overall field, when we sum them up, of E equals 2,939, and we'll go 0.04 newtons per coulomb. In checking our key, we get about 2,938.1. Okay, that probably some of that was due to a little bit of the rounding I did with the K value, but overall we're getting a value very close to what it needs to be. Okay? So the idea here is that we want to find really which of those fields is stronger at that point, and so which of them is going to overall affect our point in the middle the most. So hopefully this will get you started working through problem number 6, and make sure that you're careful with identifying that midway point as you solve. Best of luck.